Hi, and welcome to the Unit 2.1b Solutions Chemistry video, Part 3 of 3. So this is the final video in this series. We're continuing learning about what happens during dissolution. In the last video, we discussed ways of representing different types of electrolytes based on whether they completely ionize or if they do not completely ionize. And for a chemical equation, we use a single arrow if it completely ionizes, meaning all of it broke apart into its ions, and then the double arrows if it did not. And for particle diagrams, for complete ionization, everything was broken into ions, so all the products were ions. But in the case of something that does not completely ionize, we have some of it kept as molecules and some of it broken into ions. So just to recap what that looks like, we have something like magnesium nitrate. We know magnesium nitrate is a soluble salt, meaning that it dissolves because all nitrates are soluble. And so we're using the single arrow here. And so we would expect, if we start off with 3 moles of it, and we're just using 3 molecules to represent the 3 moles there, we can break it down, everything down into its ions. And of course, we follow the law of conservation of mass, making sure that we have the same number of magnesiums and nitrates on both sides. In the case where something like lead chloride, not all, most chlorides are soluble, with the exception of lead, silver, and the dimercury. So we know this one is insoluble because it's part of the exception. So we use a double arrow here. And if we start off with 3 moles of it, we have 3 moles of lead chloride. And then on the product side, we drew some of it as, or one of them I broke apart into ions. Maybe you did 2 of them broken apart into ions. But anyway, so we have that. And then at the bottom here, I just drew like this line to indicate that the lead chloride is a solid. So like there's a big clump of solids settled at the bottom of this container. And I kept those written as whole molecules because it's something that's not completely soluble. For strong acids, which are completely soluble, again, if we had 3 moles of strong acid like HI, we can break it apart into its ions. And for a weak acid like nitrous acid, if we have 3 moles of it, I chose to break only 1 of it down into ions and the other 2 are kept as whole molecules. Because this is an acid, and we would probably do the same thing for well, maybe not for all bases, not for the hydroxide bases, but because this is an acid, we are not using that solid line to indicate a big clump of solid. Okay, so we talked about the representations, how we represent it, the different types of electrolytes. Now let's go into some of their characteristics. So there are 3 categories. The first category you've heard of before, non-electrolytes. They're non-conductors because there are no ions in solution. So what does that mean? Remember, you may have seen this sort of experiment before. You can sort of hook up a light bulb to a circuit and put some probes into a solution there. And if there are ions in the solution, then current will flow, and that will allow the light bulb to light up. But in this case, since it's a non-electrolyte, the light bulb does not light up. So non-electrolytes, non-conductors. And it's easy to remember because the descriptor there match. Weak electrolytes are weak conductors. So that means that they do have some ions, just a few ions, and so that will sort of light the bulb up just a little bit. It'll be a dimly lit bulb. But there's some ions, so there's some current. Where strong electrolytes are strong conductors because they produce a lot of ions. They break apart completely into ions, and so the light bulb will be lit brightly. All right, so, well, what if you were given a compound and you were asked to figure out if it's a non-weak or strong electrolyte? So you can sort of like utilize this as a guide. Ionic compounds, and that's soluble ionic compounds. So you might want to add that little note in. Soluble ionic compounds are strong electrolytes. Strong acids are strong electrolytes as well because they are completely ionized, and strong bases will completely ionize. I kind of want to pause here to talk about ionic compounds that are slightly soluble and bases, some weak bases as well, metal hydroxide bases that are slightly soluble. They may be considered strong electrolytes, but it all kind of depends on how insoluble they are. If they're not that insoluble, then they could be under this category. Okay, for weak electrolytes, you have weak acids and weak bases. So any base that like hydroxide base that just like really just does not dissolve, it's a weak electrolyte. And then all the amines are weak electrolytes. Finally, non-electrolytes would be anything that's not ionic, so or an acid or a base. And here we have methanol, and here we have sugar. So these will be our non-electrolytes. If it's helpful to add these examples, because I don't think they're on your document, you can go ahead and add a few examples just to enrich your learning. All right, that's a bunch of information to remember, right? So we may be thinking, well, is there an easier way? Yes, there is. There's a flow chart, which you probably can't see well on your document, but I did give you a blank slide that if you needed to, you can copy it down. So for the electrolyte flow chart, you basically are asking yourself a series of questions to figure out, is it ionic? Is it an acid? What kind of base is it? And that will help you figure out if it's going to be a strong electrolyte, weak electrolyte, or a non-electrolyte. All right, so first question is, you look at it and you say, is it ionic? And if your answer to that is yes, well, it's probably a strong electrolyte. Of course, if it's insoluble, it's not a strong electrolyte. It would either be a weak if it's slightly soluble or a non-electrolyte if it's not soluble. So ionics, if it's soluble, yes. If it's not an ionic compound, the next question you want to figure out is if it's an acid. And if you say yes, it's an acid, then you want to know, is it a strong acid? So you're like, oh, if the answer to that is yes, it's a strong acid, then you know it's a strong electrolyte. Strong acid, strong electrolyte. If you found out that it was an acid, but it wasn't a strong acid, then it's a weak electrolyte. Okay, let's say you checked and you said it's not ionic, it's not an acid, so then is it a base? Okay, so that'll be your next question. Is it a base? And if the answer to that is yes, so since it's not ionic, it wouldn't be under the metal hydroxide bases. So we're just really looking at amine or molecular bases at this point. And so if it's an amine or a molecular base, then it's definitely a weak electrolyte. If it's a molecule that is not an acid, it's not a base, it's not ionic, then it's just a molecular compound, then it's probably a non-electrolyte. Like once again, an example would be sugar. So let's look at this flow chart here. For this very first one, I look at it and say, oh, this is a salt. It has a metal and a non-metal part, and I know almost all sulfates are soluble, and definitely group 1s are soluble, and it's a group 1 metal there. So, yep, strong because it's ionic, and it's also a soluble ionic. NH3, well, it's not an ionic compound, and it's not an acid, so that leads me to it being a weak base, a molecular base, so I know it's going to be a weak electrolyte. And that will be here in the flowchart. HCl, what is that? Well, it's not ionic. Is it an acid? Yes, it is. And it's a strong acid? Yes, it is. So that means it's a strong electrolyte because it's a strong acid. NaOH, so that's an ionic compound, and it also is a soluble one because it's a group 1. So it's strong because it's ionic, but it's also a soluble ionic. Next one, CH3COOH, got that Cu group there, so we know it's not ionic, but it's an acid. However, it's a weak acid, so it's a weak electrolyte. And then finally, for this one here, it's not ionic, it's not an acid, and it's not a base, so this would be a non-electrolyte. That's methanol. All right, so you can copy this flowchart if it's helpful for you to use, or if not, you can just utilize the list in the front. On the previous slide to sort of identify things as strong, weak, or non-electrolytes. Okay, so here's your final CFU. You're going to identify these solutions. There are 3 unknown solutions, A, B, and C, and they can contain magnesium fluoride, hydrofluoric acid, and CF4. So you're going to use the conductivity of each solution to identify the solution. So solution A is a weak conductor. So you got to figure out, well, which one of these could be a weak conductor. Solution B is a strong conductor, and solution C is a non-conductor. Take a moment to figure this out. When you press play again, the answer will be revealed. Okay, so HF is in solution A, and that's because it's a weak acid, so it's a weak electrolyte, which makes it a weak conductor. MgF2 is a soluble ionic compound, so it's a strong electrolyte, so that makes it a strong conductor. And CF4 is not an acid, it's not a base, it's not ionic, so this will be our non-electrolyte, our non-conductor. All right, I hope you all found this video helpful, and have a quality day. Oh, one last thing. Sorry, I almost forgot. Your success criteria. Make sure you go through this and see if you are able to do these things to indicate if you have successfully understood or learned what you need to learn for this video. All right, now I'll say it. Have a quality day.